Hello everyone, this is INE Foundation Lab 2 and section 8.2 IPv6 OSPF version 3. Okay, let's see our topology. For this section, we have to configure OSPF version 3. In previous lab, we have configured OSPF version 2 between R3, R10, R5, R6 and R4. This section R4, R6 and 5 and 3 are in OSPF area number 0, and we have OSPF area 0, and we have area 51 between R3 and R10, and we have area 52 between R6 and R8. Three, 5, 6 and 4 are in OSPF area 0. Okay, before I configure this OSPF version 3, let me explain OSPF version 3 and how we can configure OSPF version 3 and what are the differences between OSPF version 2 and OSPF version 3. Okay, let's show this topology. This is this diagram of OSPF. Okay, let's start by OSPF LSA type for version 2 and see what are the differences between LSAs in OSPF version 2 and OSPF version 3. Okay, OSPF version 2. In OSPF version 2, we have LSA type 1. It's called router LSA. This type 1 LSA stays within the area, and after to local OSPF area, it's not going to in other area. Let's see this OSPF LSA 1 stay within area. We have LSA number 1 for each area. We have 3 area and we have OSPF LSA 1 for each area. Area 0, area 2 and area 51. Overriding to the local OSPF area and contact information about directly connected links of the router IDs, IP information and client interface states. And we can see our top LSA type 1 by show IP OSPF database command. If we type show IP OSPF database command, we will still router link state. Router link state means it is for LSA type 1. And it advertises interior routes, and we see all entries in show IP route command. And we have router link state in show IP OSPF database. Okay, let's delete this one. This is okay. And OSPF type 2, it's called network LSA. In OSPF version 2, it is called network LSA. Type 1 is called router LSA, and type 2 is called network LSA. Network LSA stays within the area and are related to local OSPF area. If we see this topology, we have LSA number 2 for each area either. And this is being generated by DR or BDR. This LSA type 2, and contains information about all router connected to the multi-access network, and the DR and BDR itself, and the network prefix and subnet mask. Okay, the network prefix and subnet mask is for LSA type 2 in OSPF version 2. And it advertises inter-area routes, and we see oriented in Sharpie route OSPF. And if we type Sharpie OSPF database, we can verify this area is shown by network link state. Network link state in Sharpie OSPF database means it is LSA. It is for LSA type 2 or network LSA. Okay, and LSA type 3 or summary LSA. Okay, if we create multiple areas, for example, here we create OSPF area 0, 2, and 51, then we will have LSA type 3. The routers between areas is called ABR. This R2 and R3 are ABR routers. This ABR router is connected to multiple. In other words, it has interface in multiple areas. Okay, LSA type 3, it is called summary LSA, and are flooded to all other areas of our OSPF network, and it is being generated by ABR. If we see this here, LSA type 3, if we have multiple areas, this ABR router, it has multiple interface in other areas, and LSA type 3 is being generated by ABR. This is if area router R1 is flooding or is transferring, it's flooding router type 1, and R2, because it is ABR, is flooding LSA type 3. It is called summary LSA to other area. And R3 is ABR, it is flooding LSA type 3 to other area. It is called area 51. Okay, ABR do not forward type 1 and type 2 LSA. And LSA type 3 advertises inter-area routes, and we see all IA entries in show IP route OSPF. And it is verified in show IP OSPF database by summary net link state. Summary net link state is for summary net link state in OSPF database is for type 3 summary LSA. Okay, and LSA type 4 and type 5. Okay, let's say type 4 and type 5, they work together. If we don't have ASPR, then we don't have type 4 either. The type 4 and type 5 are so close to each other. Okay, before I explain type 4, let me explain type 5 first. What is LSA type 5? It is called Autonomous System External LSA. Okay, let's browse this. Okay, if we redistribute a prefix on router R1, for example, if we have RIP network here, and in R1 I redistribute this prefix into OSPF, we distribute this 555 into OSPF, then this R1 router will become ASBR. R1 will become if I redistribute this chip into OSPF, then R1 will become ASPR. This is how ASPR is creating. And this type 5 LSA are flooded to all other areas of OSPF network and is being generated by ASPR. Okay, if R1 redistribute this prefix 5555/24 into OSPF, then it will flood this prefix into other areas by LSA type 5. This is how our redistributed route into OSPF are transferred to other areas. And we see OEI or OE20s in show IP route OSPF, and type 5 and in show IP OSPF database we can verify this LSA by type 5 AX external link state. Okay, and type 4. This type 4 it's called summary ASPR LSA. If you see it has summary ASPR LSA. Type 3 is called summary LSA, but type 4 is summary ASPR LSA. These ASPR are created by redistribution. These are flooded to all other area of OSPF network and be generated by ABR, not ASPR. Type 5 is being generated by ASPR, but type 4 is being generated by ABR. And what is the type 4 job? It advertises the presence of autonomous system to other areas. Okay, what is infrastructure topology? Here, if I redistribute this route into OSPF, this R1 will become ASPR. Then this ABR router will flood type 4 summary ASPR LSA to other areas to inform the presence of this R1 router. This is the job of type 4. The type 4 and type 5 are working together to inform this presence of ASPR network. Okay, type 4 is being generated by ABRs. Here, actually, this should be type 4 because ABR is type 4. This is type 4. This is type 5 and this is type 4. This is how type 4 and type 5 work together. Okay, let's see on another LSA. We have LSA type 7. It is called not so stable LSA. Okay, let's show what is an not so stable. Okay, if we convert this area to NSSL, I have converted this OSPFv2 to NSSL. This area will become NSSL. Okay, this if we NSSL type 7, it is called not so stable LSA. This kind of LSA is flooded only within NSSL area. We have converted this area to NSSL, and it's being generated by ASPR within NSSL area. This is, in other words, it is being generated by NSSL ASPR. Okay, again, I have distributed this into this prefix into OSPF, and this R1 will become ASPR. And I have converted this area to NSSL. Then R1 will flood type 7 external LSA instead of type 5. Type 7 LSA are flooded by NSSL ASPRs. Type 5 LSA is not allowed in NSSL area. We don't have NSSL area in type. We don't have LSA type 5 in NSSL area. And being translated by next ABR router or NSSL ABR from type 7 LSA to external to AX external or type 5 LSA for areas outside the NSSA. And this type 7 LSA are being translated to type 5 by next NSSA ABR. This is, if I convert this area to NSSA, this R1 will become ASPR NSSA, and this R2 will become ABR for R NSSA, and this ABR will flood type 5 instead of type 7. This ABR will flood type 5 and this ASPR will flood type 7. And we see all entities, all N1 or all N2 entities in show IP root OSPF, and in show IP OSPF database we can verify this LSA by type 7 AS external link state until in show IP OSPF database. And let's quickly review our stub areas. We have stub area, total stub area, NSSA and total NSSA area. The stub area, in stub area, no type 5 LSA is allowed, no type 5, and we don't have ASPR either. No ASPR and no type 5 LSA. In totally stub area, no type 3, no type 5, and no ASPR. In an SSA, as I explained before, no type 5 LSA, but ASPR are allowed, and we have also type 3. This is the difference between SSA and stub. We have ASPR for NSSA. And in totally NSSA, we have ASPR, no type 5, and we don't have either no type 3 summary LSA in totally NSSA. This is the difference between our sub areas. Okay, and let's see what are our OSPF version 3 LSA and what are the differences between OSPF version 3 and OSPF version 2. Okay, before I explain this OSPF version 3 LSAs, in OSPF version 3 we have something like flooding scopes concept. Let me explain this flooding scopes, and I will explain this other LSA. In general, in OSPF version 3, we have some we have three more other LSA. One is LSA number 8, type 8. This is called link state. We have LSA not type 9. It is called inter-area prefix LSA. And we have LSA number 11. This type 11 grace LSAs. We have 3 more LSA in OSPF version 3. Okay, in OSPF version 3 uses the following flooding scopes. We have 3 flooding scopes for OSPF version 3. One is called link local LSA. The other one is area local LSA and area scope LSA. What is this link local LSA? Is flooded only on the local link, and is used for, or it is used by LSA type 8 and LSA type 11 or grace LSA. This type 8 and type 11 are using link local LSA. This link local LSA is only flooded on local link. Then we have area local LSA. Is flooded throughout a single OSPF area only. This is only in a single area, and are used for or used by router LSA. This is type 1. Network LSA is type 2. We have network LSA. Type 3 is renamed to inter-area prefix LSA. In OSPF version 3, LSA number 3 is called inter-area prefix LSA. This is used for inter-area router LSA. It is for type 4, and type 4 is called inter-area router LSA in OSPF version 3. And inter-area prefix LSA, it is for type 9. This is for prefix LSA. These LSA are using area local LSA scope, flooding scope. And we have a scope LSA. This is what is this? This is flooded throughout the routing domain, and it's used for this is in our OSPF. This is, and it is using for type 5 LSA. This is AS scope local LSA. Okay, this is how flooding is working in OSPF version 3. Type 4, 1, 2, 3, 4, and 9 are using area local LSS scope, flooding scope, and type 8 and 11 are using link local LSA flooding scope. Okay, now let's see the OSPF LSA types. Okay, before I explain the OSPF version 3, in OSPF version 3, OSPF version 3 distinguishes between or separate topology information and prefix information. This is the difference between OSPF version 3 and version 2. In OSPF version 3, we have topology information and we have prefix information. This prefix information is uses OSPF, in other words, OSPF version 3 uses type 9 LSA to carry prefix information. This is the difference between OSPF version 3 and OSPF version 2. Type 9 is carrying prefix information, and this topology information is carrying by, let's say, type 1 and type 2 for topology information. Okay, OSPF LSA type, we have LSA type 1. It is called router LSA in OSPF version 3. It is sent by every router. It includes the state and cost of all links. Okay, it does not include prefix information, as I explained before, because it is done by the LSA type 9. Applied to the local OSPF area, as I explained before in this OSPF scope local area, and advertise inter-area routes and receive warranties, and ensure OSPF version 3 database receive router link state. Ensure OSPF version 3 database. LSA 2 is called type 2 network LSA. It is sent by DIA or BDIA. It lists all routers in the multi-access network. Doesn't include prefix information. This is advertise interior and orientation show IP. Okay, it should be show OSPF version 3 root. Orientation and network link state in show OSPF version database. This is, let's say, type 2 and type 3. It is called inter-area prefix LSA. Send by ABR to external area for each destination in the local area. This is sent by ABR. This is working like OSPF version 2. Include link cost from border router to the local destination, and advertiser ORA routes or INTs should be show OSPF route here either. And in show OSPF database, OSPF version 3 database, we see inter-area prefix link state. And LSA type 4 is called inter-area router LSA. It is sent by ABR. This is sent by ABR. To inform this presence of OSPR. And advertise the link cost to the ASBR only, and ensure OSPF version database we see inter-area router link state. And LSA type 5 is called autonomous system external LSA being generated by OSPF, including link cost to external autonomous system destination. Further toward the autonomous system, this is a scope LSA type 5. And OE1, OE20 is in show. Show IP version root OSPF or show IP version 3 root. And in show OSPF version 3 database, we see type 5 external link state in show OSPF version 3 databases. This is the type 5. Type 7, this is called type 7 LSA. Further only within the local NSSA and being generated by OSPF within NSSA, and including the link cost to external autonomous system destination or N1 and N2 entities ensure OSPF root and type 7 AS external link state in OSPF database. The same. We have two more other LSA. This is called type 8. It's called link LSA. It's set by every router and using the link local forwarding scope, include the link local address and IPv6 prefix for this link. And in show IPv6 database, we see link type 8 link state. In show IPv6 database, it is following the local link. And type 9 is called inter-area prefix LSA. This is the prefix arbitrary prefixes sent by every router and includes any prefix or link state changes. Includes network prefixes subnet within the OSPF area and are referred to the local OSPF area. This is for the local. It is not referred on the local link. It is like let's say type 1 and type 2. It is to local OSPF area. It's referred in a single area, and we see inter-area prefix link state in show database. Okay, inter-area prefix link state is for type 9, and inter-area prefix LSA is for type 3. Type 3 inter-area and type 9 inter-area prefix link state. And type 11, it is link local like type 8. It is set by starting router and using the link local forwarding scope. This type 11 and type 8 are using link local forwarding scope. Okay, that's it. This is the difference between OSPF LSA, OSPFv2 and OSPFv3 LSAs. We have to more LSPF. And OSPFv3 distinguishes topology information and prefix information. And in OSPFv3, this is we have unique forwarding path. The unique forwarding equals to next hop address link local plus exit interface. This is equal to unique forwarding path in OSPFv3. And for configuring OSPFv3 on the interface level, we use OSPFv3 process ID, IPv6 area, and specific area number. For global configuration, we type whatever OSPF version 3 process ID. It is like MBGP. We have address family for IP version 6, and address family we specify OSPF commands like area, we distribute area number range for summarization, and filter for filter list out how we can filter our OSPF version 3 routes into areas. And okay, there is two more to remember. We have forwarding address. This is first forwarding address is selected in OSPF. Okay, forwarding address is selected on ASPR using the following rules. How forwarding address is selected in ASPR in OSPF. If there is a loopback configured on the area, then IP address of loopback is selected as forwarding address. And if the first condition is not matched, then the IP address of first interface on the OSPF interface list is selected as a forwarding area. First interface on the OSPF interface list is selected as OSPF area. Okay, in show IP OSPF interface brief command, the interface on top will be the last interface which was attached to OSPF. The first or the last interface, the last interface is the first. The first or last interface is selected as forwarding address. For ASPR. And we have P-bit. In here I explain the type 7 and being translated by next ABR from type 7 to type 5 LSA for areas outside LSA. We can verify this translation by bit number P. This bit is used in order to tell the NSSA ABR. This is NSSA ABR. We have P-bit. You can verify this here for ABR. Whether to translate type 7 into OSPF or not. We can, if we see no type 7/5 translation, it means the bit P is 0, and if we see type 7/5 translation, it means bit is P is number 1. And if bit P is number 0, then the NSSA ABR must not translate this NSSA into type 5. And if P bit is number 1, then LSA must translate. This will if P is number 1, then this LSA ABR will translate type 7 into type 5. And to verify type 1 and type 1, we can use show IP OSPF database router self-originate router number or router advertised router. To verify, let's say type 7, we can show IP OSPF database LSA extender command. Okay, now let's complete this section. This is how this was the differences between OSPF version 3 and OSPF version 2, and we have 3 more LSA in OSPF version 3. Okay, let's come for this section. Okay, let's see those topology. And now we have 9, 3 and 10 here. Okay, it's 2. The COMCO OSPF version 3 between 3, 4, 5, 6, 8 and 10. 3, 4, 5, 6, 8 and 10. 9, we don't have 9. Okay, let's COMCO this OSPF between 3, 5, 6 and 4. This what is our OSPF area 0. And follow the IPv6 diagram to number the OSPF areas for IPv6. Do not run OSPF version 3 over point over interface, only COMCO it over the gigabit interface on the link between 3 and 10. Okay, let's do this 3 part together. Okay, I'll open this area. Let's 3. Showdown pipe section. Not the OSPF. This is our OSPF version 2 configuration. Okay, let's configure this. Okay, let's configure the OSPF version in interface level. Let's see topology. Between 5 and 10, I have this interface 1.33. Okay, do show IP interface brief. This is this 1.30. This is this interface. This one. And OSPF version 3, this is area. I will process ID of 1. Then I can specify IP version 6 or IP version 4. I will specify IP version 6. IP version 6. Okay, this OSPF version 3 it is like MBGP. We have address family for IP version 4 and address family for IP version 6. And area, this area number 0. And I have another interface for this 10. It is called 1.103. Let's go under this interface. This is this interface. interface. This is in OSPF area, OSPF version 3. Besides that one, I use IPv6, and this is area 51. That's it. If I do show run pipe section dot OSPF, I have created, this is water OSPF version 3 episode 1. This is called global OSPF. We have address family IP version 6 unicast under this water OSPF. This is OSPF version 3 configuration. It is created automatically after I have configured interface level configuration under this interface. Okay, now let's go on our file. Show IP interface brief. For between 5 and 10, I have this interface config t interface, this one. Okay, this is in area 0. OSPF version 3 and process ID should be 1, and I specify IP version 6 address family, and area is 0. Okay, this RS is up, membership is up between 3 and 5. Between 5 and 6, I have interface. Let me see what is my interface. I have this interface. Interface. This is the same command. Then on 6, show IP interface brief, config t interface, this one. I have the same command here. Membership is up. On 6, I have 3 more interfaces. 4, 6, 6, 8. only this interface. I have only this interface in OSPF. This 146 is for EIGRP interface configuration. We have two more. One is 1.46 and 1.68. This 1.46 area 0. Okay, 1.4 interface 1.46 area 0 and interface this one in area 52. OSPF version 3 plus idea 1, IP version 6, area 52. And on this component 4, show IP interface brief. Config T interface 46. Area 0. And in 8, config T IP interface brief. Do show brief. And I have this interface and OSPF version 3 plus idea 1, IP version 6, and area should be 52. Okay, this is how we configure OSPF version 3 but this one version 6 between these all devices. If I do show run pipe section rotate OSPF version 3, OSPF version 3. Okay, this is our OSPF version 3 configuration for all of this network. R10. Go after configure. This is show IP interface brief. And interface is 103. This interface. Config T. Interface this one. And OSPF version 3 plus idea 1, IP version 6, and area is 51. It's done. Okay, let's this is done. The follow-up event diagram number area and do not run OSPF over the point interface, only compile it over the gigabit 103. Okay, this is done. We are only configuring this interface between R3 and R10, 103 and 103. Okay. Okay, now we distribute the loopback 0 networks of all OSPF devices into OSPF version 3. Okay, let's redistribute our loopbacks. So start by R3, create route map, let's call it, this is connected to OSPF version 3. And match our loopback. Match interface loopback 0. Undo shutdown 5 section router OSPF. I'll go to this router. I'll go to on the address family, and here I'll type redistribute connected and specify a route map and a route map name. This is connected to OSPF version 3. That's it. Come verify, yeah, but do show OSPF version 3 root. Okay, this is external root list, and these are interior root list, and we have interior root list. This is the loopback of a Okay, we have distributed on our 3. Okay, good. So let's redistribute our 5. Config T route map connected to OSPF version 3 and a match interface loopback 0 and do showdown pipe section .ospf under .ospf version 1. Add this family unicast. I tap redistribute, connected our route map, and connect to OSPF version 3. Let's see this. Do show OSPF version 3 root. Show OSPF3 root. And external root list is this one. And at 6, if we do show OSPF version, as I always forget this F1, OSPF version 3 interface brief. Show OSPF interface. Tell me on which interfaces I have conquered OSPF version 3. This is 46 through 50 and 68. It is called update interfaces. This is in OSPF. Yeah, 50 and this 2 1. Okay, now let's redistribute with map. Connected to OSPF version 3 match interface loopback 0 and do showdown pipe section .ospf version 3 on this address family. I type redistribute, connected, I type root map, and specify our route map name. Okay, and now let's verify our file to show OSPF version 3 root, and we have this interface of 6. And let's go on. For route map connected to OSPF version 3, match interface loopback 0, and do showdown pipe section rotate OSPF version 3 under this address family. Redistribute connected and specify route map and route map name. On our 6 to show OSPF version 3 route, and I have 4 loopback 4 here, but you have water 4. Okay, let's on 4, 6. On 110, I have to dispute on 10 and 8. Do showdown. Let's copy and paste this configuration for quick. Add background OSPF to master interface 0 on 810. 10, not 8 is for 8, and this is for 10. And do showdown pipe section with the OSPF version 3, and we have this connected to OSPF on 8. And 10. Three, do show OSPF version 3 root, okay, we'll have for 4, 5, 6, 8, and 10. These are the external rootless LSA. Okay, 4, 5, 6, 8, and 10. We distribute these two packs into OSPF, and on our R3 I can verify this on the external root list. Okay, this is this part. Okay, ensure that R10 does not receive any type 5 LSA. It should be run type 7 default root, format 3 for external reachability. Okay, let's wait for R10. Do show OSPF version 3 database. OSPF. Okay, we have type 5 external LSA for our loopbacks. Take this for 3, 4, 5, 6, 8, and 10 on R10. This, I have distributed the loopback and I have distributed this LSAs. Okay, here it said R10 does not receive type 5, it should grant type. Okay, it means we have to convert this area into NSSA. What is the NSSA? No type 5, ASP is allocated, and to convert we use the area number NSSA command. This is the type 5, only type 7 LSAs allocated in NSSA. NSSA, we use type 7 LSA. Okay, let's on 3. Um, 3, oops, 3 10, and it says it should rely on type from default root from R3. Okay, I will use default information originate command here. Default information originate for our NSSA. Okay, let's see on our team we have T and 10. On 3 I use do shutdown pipe section hotel OSPF version 3. Hotel this one and the others family. I tap, I comment this area 51 to NSSA. This is how we comment this area to NSSA. And we have default information originate. This originate type 7 default into NSSA area. Default information command after NSSA. This originate type 7 default into NSSA area. This is how it is required. It should only rely on type 7 default root from 3 for external reachability. And I type default information originate here. And another 10. Do shutdown pipe section OSPF version 3 on this and others family. I'll convert this into NSSA. Area 51, it should become NSSA. I'm done. Now it's on 10. Excuse me. Show OSPF okay, I have insert root list and this is one default and then show OSPF version 3 database. I don't have type 5 anymore. I have interior prefix. Okay, I have type 7 external LSA. So 3 and 10. Okay, this is our hotel link, network link, and this is type inter area. This is type 3. This is type 8, and this is type 9. Inter area prefixes for type 9. Okay, let's show IP version 6 with OSPF. Okay, in show IP version 6 OSPF, I can see OI, ON2 parameters. But in show OSPF version 3, we don't have see different. I have see by this with NSSL, root list, and so on. So the differences between this command. ON2 and so on. Okay, our turn should receive summary for IPv6 internal links. These are 46. There should not be any more specific rules for this range in R10 clip. Okay, let's see this R10. This is for physical interfaces. Physical interfaces. 156, 1, and others. I have to summary up this on R10. I have to see this root as summary in R10. Okay, on 3 I have to do summary. By arrange command. Okay, and let's go configure. I'll go this one, add this family, and I tap area 0 range. I have to this range command will summarize our prefixes. 1, 156, 1, 28. Let's verify. Okay. mm, I have summarized this networks into this one, but this area range command cannot filter this network. I can I, I have to use area range and or I have to use OSPF filter to filter this network. Okay, and let's use create IPv6 prefix. Yeah. Okay, IPv6 prefix. Filter. Let's filter this and let's sequence up 3. So 5 and then paste. Deny this prefix first on a 10. And permit all other less than 128. Okay, and then under this one filter area 3. Let's go under this one. Go to OSPF3. This family unicast and our filter list area 0 filter list and p and on the filter list we have a prefix and filter out. Okay, done. This is now I have filtered, summarized all of this into this one. For physical interfaces. I have used filter list and R3 for summarizing this one. Okay, and R8 should receive an interior default from R6. Let's see, R8 roots. Show OSPFv3 database. I have LSA type 5. Then I have to convert this into an SSA. On 6 area 52. An SSA on 6. I'll convert this into an SSA area 52, and it says interior default. Then on 6, what is 6? I type area 52 an SSA, and no summary. What is no summary is doing? It is calling totally an SSA. No type T, no type 5, it's all the way down totally an SSA. Let's check here. And X8, let's let's have to convert to an SSL. Let's convert this to an SSL. Config T usual run type section rotate OSPF version 3. Add this one, we have a unicast a 22 on an SSL. To show OSPF version 3 database, and we have type 7 for .NET 4. Okay, now let's verify our connectivity, and this is let's see on RT, and I typed CLS command, and this is going to become this, and type P-bit. Okay, these are not for our network. So this interval for switch, I have 4, 3, 4, 5, 8, and 10. I have to verify this on 10. Then look back. And 64, 46, 56, 68, 1, and 10. Because these are networks. Let's verify this network. To do power 4 switch, exit this TCLS, this one, this interface, this one, verify this, and pin. And everything is I have connectivity for all of my loopbacks. Yes. Okay, this was our this section of OSPF. I have compared OSPF version 3 between all of the devices and distributed loopbacks into OSPF, and I have filtered and this part I converted this into NSSA on this network. I converted this into NSSA between 3 and 10, and I better the default input originate on R3 for external reachability. And for this section, I have summarized these internal links by area range command on R10 on R3, excuse me. Show down part section OSPF version 3 area range. For another route, I have used a range filter links and created IPv6 prefix links, and I have filtered that route by area0 filter links on 10, or if I type on 10, it would show OSPF, show IP version 6 with OSPF. I have this route filtered. This is this one. This range. I have filtered our internal links. I can wait for show OSPF version 3 route. This is our internal links filtered by area on R10. And this is our default for this part. And on R8 should receive integer default from R6. Then I have converted this area on R6 I have converted total NSSA, and R8 I have LSSA. I can verify this on R8. This is actually the database, and I have connectivity between all of this network on R3. That's it. This was our IPv6 OSPFv3 section. I hope you have enjoyed this video, and thank you for viewing.